Hello, Deb Gaff here, and I'm going to be talking about teaching technology with technology. The expectation for students in AP Computer Science Principles has increased substantially with the 2020-2021 revision by the College Board, especially the requirements for the CREATE task where students write and document a program showing their mastery of computational skills. My student learning objective is that students should be able to design an algorithm that can be used by another student to create code that includes sequencing, selection, and iteration with 80% accuracy. That's for this little mini unit here. That is not the end product by any means for this class, but it is for this little mini unit. In this lesson specifically, I'm looking for the ability of students to write an algorithm that a programmer can use to write a program with a high degree of accuracy. I included a target of 80% accuracy for students. Ideally, I'm looking for a much higher number, but this lesson can be revisited throughout the school year so that students have an opportunity to improve their craft. I expect a mixture of students in the class. Some students will come into this class with a great deal of experience working with computers, even computer programming experience. On the other hand, I'll have students who come into the class who are new to computer science and maybe haven't even thought about computer programming and maybe aren't even the most proficient users or consumers of technology. And I want everybody to feel welcomed. I truly believe that all students should take a computer science class because computers are ubiquitous. They're everywhere in our world. There are millions of lines of code in my car. No matter what you do, or what your future looks like, computers are bound to play a very big role in making sure that you're successful. So in order to make sure that I am successful as a teacher, the tool I'm going to be using to evaluate the effectiveness of my instruction is Karen Hess's cognitive rigor matrix, especially the one that she created for her career in technical education. I want my students to go from this level 1, where they just have a basic understanding of what an algorithm is, to level 5, where they have a conceptual understanding. One of the things I need to be cautious of when teaching anything to students is I don't want them to learn something that's just rote memorization. I want them to learn new knowledge, build a toolbox, and be able to use the tools in that toolbox to solve new problems that they haven't seen before, and not really rely on, well, she didn't teach us that in class, so I really don't know how to do that. I want them to take that knowledge and use it to do just about anything. So the instructional strategies that I'm employing this lesson are Cagney's 9 events. So we're going to start with a gain attention, that first set there. Gain attention, state the objectives, and activate prior knowledge. And one of the things that I think is the most important here is to activate that prior knowledge. So Dr. Hermann Ebbinghaus noted the following. He discovered that without any reinforcement or connections to prior knowledge, information is quickly forgotten, about 56% in 1 hour. That's a lot. 66% after a day and 75% after 6 days. This is quite a big deal because this is one of the first lessons I'm going to do in computer science principles. And if this is August and my students are going to take the test in May, I can't allow them to forget this. So I really need to build on something that they already know and understand and feel comfortable with, and then keep the the learning fresh by revisiting it throughout the course. And the second step, proceed with content delivery, set interim expectations, and continue to monitor student progress with formative assessments. And finally, to be sure that all students receive feedback, not only on individual assignments, but how are they progressing towards the overall goal. During the learning from home this spring, I had a student reflect on the class, saying that it was really important to him, and he was grateful that I provided immediate feedback and constructive feedback on everything that he submitted. He said it just took the stress off knowing whether you'd gotten it right or not, because you weren't sitting in front of a teacher or next to a teacher to be able to ask, specific clarifying questions. So it helped reduce that level of anxiety. And of course, to personalize the learning, well, in this case, the students are taking this level of class because they hope to obtain college credit, that they feel it's a necessary class for their future. And I just want to make sure that those goals and needs are being met. So I always like to begin my class with the end in mind. So what is our end game? What is it that we're trying to achieve? I liken this to the gaming world, because what students know about gaming is what does winning the game look like? And then they develop the steps, their algorithm to creating a strategy that's going to help them win that game. The other thing I want to do is I want to present to them this sort of what looks like maybe to some students a complex algorithm or rubric of how their work is going to be judged. So what we want to do is look at this and say, what do you know? And what do you need to know? And I'm thinking that students are going to look at the vocabulary under the scoring criteria column and say, whoa, wait a minute. What do they mean by sequencing, selection, and iteration? And what is an algorithm anyway? And that's going to create the need to know so that they are invested in what's going to happen next, because they already know that their end game requires knowledge of this vocabulary. So then I break it down into individual standards. So there are going to be many steps along the way. This isn't like, okay, you're going to do this really complex algorithm and code, and you're going to do it tomorrow, and that's your assignment. No, we have some small steps along the way. And our first one is simply develop an algorithm. Express an algorithm that uses sequencing without using a programming language. And I try to give my students reassurance that, hey, you already know what an algorithm is. You've been using algorithms nearly all your life. Let's embrace our first grade self and remember when our teacher said, okay, it's time for lunch. And that was her cue for you to follow a series of step-by-step instructions to prepare for lunch. So you would put away your materials, you'd stop talking, you stood up, pushed in your chair, you got into a straight line, and so on and so forth. And that, my friends, is an algorithm. So in computer science, we just have really highly specialized names for some of the things that you already know how to do. So my first technology that I'm going to use in this class is an unplugged activity. So think of technology loosely as technology is any tool that helps you complete a task, complete a job. And this is a gentle way to introduce algorithms to students. So what we're going to do is take a look at the grid on the right, and the star. We're going to explain to the star how to move through the grid and when we want the star to fill in one of the squares in the grid. And this is pretty simple for students, and it makes a connection to them, for them. Algorithms are really pretty easy to write. It's something I can do. It helps build confidence. It helps those kids who are not the most technical say, yeah, I think I'm going to be successful in this class. Then we're going to move on a little bit, and we're going to take what we have worked together in a class, and we're going to learn how to write our own algorithms. We're going to show that we know how to write our own algorithms. So what's going to happen is a student is going to pick one of the images. They're going to put a star where they want their star to start, and then they're going to write an algorithm for that star to navigate the grid, and when that star should fill in one of the squares on the grid. And to test, so this is an informal formative assessment, is is an opportunity for them to write that algorithm and then pass it on to a classmate and see if their classmate can correctly create the image that they sought to create with their algorithm. And depending on student success, we may do this once, or we may do it 2 or 3 times, depending on where we are and how comfortable do they feel with this. The next technology selection that I needed to use for this lesson was to find a development environment for the students, because ultimately they need to write code. And I spent a lot of time, really went down the rabbit hole here, trying to find what I thought would be the best technology to use for my students. And given the wide variety of students that I anticipate in the class, I wanted to use a block programming language, but I really wanted a block programming language that was sophisticated enough that would appeal to middle school and high school students. Sometimes students look at Scratch, which you might be familiar with, and it presents with this cute little cat at the beginning, and some students, quite frankly, are turned off with that because they're like, oh, this is so juvenile. So what I found was Snap programming language. It's very similar to Scratch, but it doesn't have that, or let's put it positively, it has that more sophisticated kind of look to it that I think the students will appreciate. And it has a few more constructs that will help build background knowledge for students if they want to continue taking computer science courses, specifically computer programming courses where Python or Java, that they've already started to hear some of the terminology that we will employ in a text-based language. The very first thing that I do when I'm introducing a new technology like this for students is I give them a really quick demo of the tool that they're going to be using. So in the top left-hand corner, you'll see that there are motion, look, sound, pen, etc. Those are called palettes. And I'll go through each of the palettes. We'll kind of take a look at what elements are part of those palettes, and maybe show a couple examples of how they might be used by the students. Explain to stage how to find new sprites, how to set a background, just some general, here's a general feel for how the program works. And then what I do is give them sandbox time. And I think this is an incredible tool. It's incredibly important for student success later. So this is an opportunity to explore something new without worrying about having an assessment, to go ahead and make mistakes, to problem solve. I love productive struggle in the classroom because I can see when students are trying new things and learning, and because you get that, oh look what I discovered, and then they turn their computer to show someone else, and that's pretty exciting. I also am worried about learning from home, if students are learning from home, because I don't like productive struggle as much then, because I cannot tell when a student is continuing to be productive or when they start to become anxious because they can't figure something out or defeated. So if I would use another instructional strategy here if I were in a learning from home situation when it was time to teach this lesson, and then I would create a video of all the different things that you could do with this software to give my students something that they could refer back to and help them create something. And what I would have them turn in for this is, what did you create? Did you find something new in one of the palettes that I didn't show you how to do? And what can you do with that? So just to kind of show off. I might even have some students display on the screen if they for the whole class to see, so that they can kind of show off what they've learned. All right. Our next step would be then to go ahead and move students beyond the unplugged activity of algorithms, but to write an algorithm and then translate that algorithm to code. So they have both the skill sets now. They know how to use the platform and they know how to write an algorithm. So I would create a live document at this point, whether it be a PowerPoint slide or a Word document or Google Doc. And as a class, we would go ahead and write an algorithm to have the sprite on the screen draw a square. And so what we're going to do is create a sequence of instructions. And so now I'm introducing that second vocabulary, algorithm now sequence, right? And then they're going to go ahead and code that based on the algorithm that we have just written as a class. And then we're going to look at it and we're going to say, wow, you know what? That's a long algorithm. That's a lot of code. Do we see any patterns here? Yes, of course we do. We see that we're repeating the move steps in the turn 90 degrees. We need to shorten that. And we're just repeating the same steps over and over, or the same code over and over again. So let's use a construct that helps us reduce the amount of code. So we're going to use a repeat loop, and we're going to tell it to repeat 4 times, and this is called iteration. So now we're introducing some more sophisticated vocabulary for the students. So then, once we know how to make that square, what I want to do is ask students to go ahead and expand what you know. Show me that you can create an algorithm to create something new that the turtle is going to draw on the screen, the sprite is going to draw on the screen. And I'll give them some suggestions. Hey, maybe every time you make a square, you move to a new random location on the screen. Maybe you move to a new random location on the screen and you change the color of the sprite, or the line that the sprite is drawing. There are a lot of different things that they can do, maybe you have some very sophisticated users and they ask for how many signs are you going to have, and I know how to calculate that, and I know how to use variables, and this is a great assignment because it allows students to participate at whatever skill level they're comfortable with. This also gives me an opportunity as a teacher to take some time to reflect on what students have done so far and how comfortable I think they feel with the environment and coding. So I could scaffold students here by providing them with some starter code, providing them with, here are some blocks that you might want to use in order to make this happen, and then give them the opportunity to put those together. And finally, this is an example of some more sophisticated code that we're going to be looking at later. What I want to do is continue to use algorithms throughout this school year. This is a pretty complicated program. It's a little catch the sprite game. There are several sprites. There are procedures. There's variables. There are lists. Maybe I'm not asking students to write an algorithm for the entire program at this point, but if they create a procedure, maybe I'm asking them to write an algorithm that explains that procedure, that step-by-step instructions for that procedure, creating that procedure. Again, then sharing that with a classmate. Can the classmate recreate what they've created? So the important thing is to continue to revisit this material, algorithms, sequencing, iterations, and then we're going to be adding things to that selection, so if statements, conditional statements, things like that, and just to keep this fresh and current with students. Thank you.